Hello everyone, welcome back to the channel. I know it has been a while since my last upload, and I want to start by thanking you for your patience and the continued support. Over the past months, I've been working on the reviewing of your comments, questions, and also video requests based on my previous videos, and which I think now I've been able to prepare a series of content based on the really research problems which I found that the many of my subscribers are experiencing. Now, this videos marks the beginning, the beginning of that series. So from now henceforth, you can expect at least 3 videos every month, all focused on applied, publishable, and defensible research decisions, not just commands as you have been doing before. So if you are new to this channel, kindly consider to subscribe, share, comment, and also give suggestions, so that I can be able to get more content for you. So before we embark into today's video, let me appreciate all my subscribers, and also for the new community, for new subscribers, please join this community and we grow together. We are heading almost 1,000 plus subscribers, so the community is growing. And also let me take this opportunity to wish you a happy new year, 2026. As we get starting this new year, this new month, let us work together and hope for the best. Thank you. So today's video is part one of a short series where we clearly explain what missing data really means in applied research. So starting with missing completely at random and how to think about it correctly in Stata. You get it right? So that's all about today's video, and I'm going to share. I have a presentation for that, so you can see what missing data really means in applied research. So I'm going to show you a data which we are going to use actually in a practical aspect. Then some few slides to guide you on how, or to guide me on how to handle this problem. So in my today's data, I have a data here. Actually, it has, as you can see, it has 6 variables and 120 observations. And if, as you can see on this data, okay, of course, we have variables like the ID, the age, educational level, income. This again is supposed to be annual income in USD. So we have job satisfaction and healthcare score. If you are keen, you can be able to see in between this data, especially the income, job satisfaction, and health score, we have missing data. And I assume you know in this data, missing data are being presented or represented by a dot. So if you see a dot anywhere, then it means now that's what we call the missing data. Or in like the Excel, it can use NA to represent that. So this, you can be able to see missing data. So my key goal today is to tell you, how do you know whether this missing data is really missing at random, or is really missing at completely at random, or not at random. So that's my objective. So for specifically part one is about we are going to talk about missing completely at random. So we are going to discover how, whether this data is missing, if you have a data, is it really missing completely at random or not. So there is a test that we are going to use for us to discover that, because I discovered most majority of my most of my subscribers, actually they reached me out, and they had a challenge on making decisions which exact approach would they use in their data. So it was difficult for them to say whether, first of all, I asked them, is your data, I was asking them, is your data missing at random not at random or completely at random. So it was difficult for them to discover that or to answer that question. So I'm here today to answer that question for you. So before we move on, so now missing data is not actually a software problem. That's something that we need to understand. Now that you have seen the data that we are going to use, so let us just have some bit of theory before we go to the practical aspect to answer our question or our today's question, whether this data is missing completely at random or not. Now, first of all, you need to understand if you are working on your research, if you are working for an NGO, you are working on maybe a personal project, and you are using, let us say, survey data. And this survey data, actually, majority of them is the one that has this missing data. Like in medical what? In medical field, so we have data like national health nutrition, actually, which is a database, a survey database for US. Yeah. So we have NIH. So those are the database actually where you can find survey data, which is done on a big number of individuals in the United States. So, like if you go to that data, you find out that the majority, that at some point they are missing data. Like the one for national health nutrition, you find from the year 2019 to 2025, let us say to 2024, they will tell you that the data, they did not actually carry out the complete survey due to COVID-19. So they have given the reason. And still we have missing data in that data. So when you have such kind of reason also, you are able to know exact approach to use. You understand? So that's why we say that now in this, like in this video, I'm starting by saying that missing data is not a software problem. So sometimes there are underlying reasons or factors that you need to consider or you need to understand before you make a decision. So missing data affect bias, not just a sample size. Exactly. So if you have 1,000 observations, which is equivalent to a sample size of 1,000 individual, then in that 1,000 you have let us say 20% missing data. Then that missing data doesn't affect the sample size, it affects the biasness of that data. Because if you are going to do a simple regression model, then it means automatically regression the model, the system or the software automatically will drop those missing 20% missing values. So we are going to have some biasness because we ignored that missing values, but the software automatically has let it go. And in the other one now, it will bring some biasness in our end results. Also, the software only implements the assumptions you choose. So as a researcher, you need to make a right, you need to be sober in making your decisions or like in implementing your assumptions. Just check on the data and be sure on the assumptions that you are going to choose. Automatically, wrong assumptions leads to invalid inference. Yeah, if you make a wrong assumptions, then it means at the end of the day, everything is going to be wrong. The in financial statistic and all everything, like so on, it will be wrong. Then lastly, journals reject papers due to poor missing data handling. This is a big issue. I've handled a number of publications in terms of statistical analysis, like yeah. So I found out that a paper can be rejected or it can be deferred to an author simply because there is no section under methods or under methods that clearly states how missing data was handled. So even if your data does not have missing data, it's good you have that section in your journal, in your paper, such that if you don't know, if you don't have missing data, you can have it. Then you say based on this data there was no missing data. That's okay. But assuming it will bring a problem. But let's assume we have 20% missing data or 6%. You have to mention under that section and how did you treat those missing values and how you make how you came up with the final decision. So it's good you do that. So once you understand that, then it means your paper is going just to be accepted. You're not going to have some issues with the maybe the editors and the reviewers. Why most papers get missing data wrong? So I know there are a number of papers already published online, especially medical, socio, like you understand. So and they have missing data, yeah, but there are some like the way they have handled it is wrong. It's not the correct manner, and that's where this video comes in to enable that visual research should be consider all the aspects and all the assumptions to ensure that they give reliable output or credible papers out there. So number one, they treat missing data as a technical inconvenience. Yeah, that is true. You get it right. So you have the data, you have encountered missing data, then what next? You assume, you ignore it, and you move on. Then that one now becomes an issue. So they tend to treat it as a technical inconvenience. Number two, they assume missing at random without justification. This is a big issue. So you have a data, that's missing data. Then you want to complete your research paper or your project. So what do you do next? You just rush to multiple imputation. Technically, like you rush to statistical approaches actually which rely under a missing at random scenario or option. Then next, the use of default commands without the diagnostics. That is it. So you don't majority they have just used the default commands given by the systems or the softwares and so on, and that one also you see it gives wrong information at the end of the day because you have not done all the diagnostics. It creates a problem. Lastly, second but not least, they ignore data generating mechanisms. So if you have a survey data, for instance, the National Institution Health Institution NHI data, so there's a way they have explained on how the data was collected from the individuals. Well explained and well put. So in your case, if you find maybe some people they ignore such kind of the readme options or the recommendations for them to understand how the data was being collected and how, unlike in majority of those um, surveys, big surveys, so they have explained on how this survey was being carried out and how you as a researcher how you are supposed to treat it. For instance, the National Health and Nutrition Examination Survey, they have clearly indicated how the data was being corrected, and if you are doing the analysis, you have to use what we call survey settings. Survey settings to ensure that now it covers the entire nation, like it represents the national population. But also they have clearly indicated, like for instance, the National Health and Nutrition Examination Survey, they have clearly indicated why you cannot use imputation. So in that case, if you rush and use imputation, then it means if you publish that paper outside there, then that result will not be ripe. Understand? So we need to understand all of this. Don't ignore how this data was being generated. Just read the documentation. Lastly, the confusion with this, most individuals or researchers, they confuse imputation with data recovery. So if you have 20% missing data in your data, then it means if you use imputation, it doesn't mean that you are recovering that 20%. No, that's not a data recovery approach. You need to understand that, and we are going to see that practical. Good. Now today our main video was all about this now, missing completely at random. We say that missing, this is actually, by the definition, just a brief definition, missing at random is a scenario where the missingness does not depend on observed or unobserved variables. This means there exists no any systematic pattern which makes the missingness bigly at random. So for instance, the data that I'm going to share or that I showed you earlier, the job satisfaction is an example of missing completely at random. Now we are going to see that practical. So example, random survey dropout due to server failure. So that becomes a scenario as well. Now, one thing you need to know, missing at random, completely at random, allows unbiased complete case analysis. Of course, it's a rare case. So it means that if you have this missing completely at random, you can use what we call complete case analysis. So it may lead to loss of statistical power, but it is a valid approach. You understand? Even though, okay, you can use multiple imputation as well, multiple imputation in this case, but it is what it is. I can put it is less reliable, compared to other scenarios, like missing at random. But in this case, you can only use, you can use, of course, you can use that multiple imputation. Still, there are factors that you need to consider. But the best approach, which is actually a simpler method you can use, is what you call complete case analysis. It will yield what we call unbiased results. Now, the next thing is what moving to next thing, what Stata can and cannot test. So for this missing complete at random, if you have data and you want to be sure, number one, you want to be sure that if this data you are going to apply multiple imputation or not, or you are going to apply a complete case analysis or not. There is a test known as a Litros missing complete at random test. So it tests only, unfortunately, this test it tests only missing completely at random data, not missing at random or missing not at random, and it cannot distinguish these two, missing at random or missing not at random. It cannot distinguish that. That is something that you need to understand. Number two, no statistical test can confirm missing at random. So many individuals have asked me, how do I know that the data is missing at random using a statistical test? Unfortunately, there's no statistical test for that, but you can use what you call, you can justify it by conceptually. You can, so you go there, you look some theories and some tests some studies that have already been done, and you justify that. So that is in fact you need. So now, given this data, so this is the data that I was showing you. So it has the education level, income, job satisfaction. So what I'm going to do is I'm going to show you how to discover whether your data is missing completely at random. So that's so that you can make a decision. So we use what you call so if I use the MDesk, I can be able to see the health score, job satisfaction, income. They have 20%, 70%, 17.5% missing data, respectively. And now my main thing here is to test whether this data is missing completely at random, so that I can be able to see which approach I will move on with. So what I'm going to do, use what we call, there's a command known as missing completely at random test. But this one, for you to install it, you need to install first. So what you need to do, just use help, then the command, put the command, then it will bring you see there will be what, there will be a new window. So in that window, so you will because for in my case I've already installed it, so there's this option, so you can go to this option ST0318 and you can be able to just install it from there direct. Then next, you must list the command followed by the variables you have in your data. But there's a rule. The first rule for you to use this little missing complete at random test, which is actually by definition, this is a statistical technique used to assess if the missing data in a data set occurs completely at random or not. And it does also it is what it does also what we call the null hypothesis. Again, the null hypothesis for this test is that the null hypothesis is that the data is missing completely at random. That's the null hypothesis. The alternative is the otherwise is the alternative hypothesis. So the rule number one to use this says you must ensure that you include variables with missing values. Include all the variables with missing values, at least 2. So there must be 2 and above. The number 2, you must include fully observed variables. Like the fully observed variables, I mean the variables with no missing data, at least 1. So you can use 1, 2, 3 and above, as long as they have complete data. So that's the rules for you to use this test. For instance, in our data, you realize in our data, if I look at this table, job health score, job satisfaction, income, these 3 variables, they have missing data. But the only variable which is actually a continuous variable, a variable with what? With the 0 missing data, we can use is education level. So what we do now in this test, in this command, I just put the command just like that. Then followed by the age, education level, income, job satisfaction, then health score. Just like that. So we have like the age, you can see it has 0%. So the age now as well on the education level, actually they are acting as fully observed variables. So once you do that, just execute. Good. So we have now the output for this missing completely at random test. We normally call it retros test. And now it's time to make a decision. So it says that if the b value under chi-square test, if it is less than 0.05, actually it's less than 5%, then you reject the null hypothesis. You understand? If the b value is less than if the reject the null hypothesis if the b value is less than 0.05%. Then it means that if you reject it, okay, that's a decision. Number 2, if the b value, this chi-square b value is greater than 0.05% or greater than 5%, then we fail to reject the null hypothesis. Then obviously we say that our data is missing completely at random. But now in our case, the b value is less than 0.05. So what do we how do we interpret this? So we can say that since the b value is less than 0.05, it is evident that the data is not missing completely at random, indicating missingness is related to observed data. And now we have made a decision up to that point. So it means using this test, we have been able to discover that this data is not missing completely at random. So then it means we have made it missing at random and missing not at random options for us to see how we can do it, how we can handle this missing data. So what we have learned from this video is that only missing a completely at random scenario is testable statistically. Number two, missing completely at random is rare. That is what we have learned. And we can, it's the only case where list-wise deletion is defensible. All the complete case analysis, you can use it and you defend it in your, like in your paper. So I think now up to that point, we have learned how this how to discover whether our data is missing completely at random or not before we maybe make any decision. So if you have any question, any comment, any suggestion, you can just comment in under comment section. Yeah, if you have any question, you can you can just reach me out. So yeah, so if you are working on a thesis, dissertation, journal paper, or a broad research project, and you need maybe support with data handling, missing data, multiple imputation, or publication data analysis in Stata, feel free to reach me out. So I have a consultation. Yeah, that's the good news. I have a consultation. I have consultation. I have a training, private training, and a project-based research support. So you can contact me directly via the email. So this is my email: wilfred.researchanalytics@gmail.com. So in the next video, part 2 will focus on missing at random and why multiple imputation is usually justified but often misused. Thank you for watching. I'll see you in the next video.